Hey guys, so we're going to go into Unit 8, Lesson 3 and look at the laws of logarithms and how to simplify logarithmic expressions. So this is just expanding further on the properties that we looked at in Lesson 2 and adding some to that. So in Lesson 2, I kept stressing how much logarithms are equal to exponents. And so that being said, all of the rules of logarithms follow our rules of exponents that we did when we did exponential equations a while back, and just polynomials in general and those rules of exponents. So there's two things you'll be asked to do. Depending on the equation, it may be easier to do one versus the other. So you're either going to be expanding, making bigger an equation, or condensing, making smaller an expression. A and B in our examples and lowercase a will all be positive values. Lowercase a as the base will never be a negative, or will never be 1, excuse me. And c will always be a real number because we have it in the exponent position. Okay, so there's 3 laws that we really want to look at. This is condensed, but just like with exponents, we can expand this. When we multiply, we are adding. So this is the same as log base a of a plus log base, log base a of b. All right, so we switch from multiply to addition and just split that number up. Now that can be any number. You can have 2 things in there, but it could also be like log of 21, and you can rewrite that as log of 7 plus log of 3. All right, so it can be factors of that, or if this says like 3x, you could have 3 and an x. Okay, so this one doesn't go any further. Doesn't really benefit us to expand that, but in some cases it will. Division, same thing. We can rewrite this into 2 different components and expand it out. Division goes to subtraction. So log base a of a minus log base a of b, and we split that into a subtraction problem. Right. For this one, and we saw this a little bit in lesson 2 in terms of these canceling out and the fact that it was equal to the exponent. That is because power to power, and we have a log, which is an exponent, raised to another exponent, we're actually going to multiply. And so we can move the c out to the front and multiply them. So c times log base a of a. All right, so again, when you're multiplying, you're going to switch add. Notice that our bases are staying the same when we split that. All right, when we divide, we're switching that divide to subtract. And then down here, we're moving that c to the front. Okay, but all through it, those bases stayed the same. We've never changed our base. Okay, some things to be careful of. All right, log base a of ab to the c is not the same as c log base a of ab. All right, that c is only on the b. And so what we could do for that is first split this into log base a of a plus, because this is multiply, log base a of b to the c, and then we can move it to the front of that one. So log base a of a plus c times log base a of b. All right, so it only applies to the b. It should only be with the b at the end. Okay. But this one is outside of the parentheses, so it applies to both. Everything in there, you could distribute it if you'd like to both the a and the b. So we can move that to the front. Okay, then for the end here, it would be on the front of both. All right, so when you're evaluating, you want to be able to expand or condense depending on how it will help you solve that out. Okay, so if you have log base 2 of 160 minus log base 2 of 5. Sorry, my pen got stuck on there or something. This doesn't help us. We can't solve log base 2 of 5. All right, so we can condense this and change it so that it's log base 2 of 160 divided by 5, because this divides evenly. All right, well, then that's equal to log base 2 of 32. Okay, from there, I can convert that to an exponential equation. 2 to what power equals 32? All right, well, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32. And so x equals 5, which means this is equal to 5. All right, or log base 2 of 32 is equal to 5. Okay, so sometimes condensing it helps you be able to solve it faster. Same thing here, log of 1 over the square root of 1,000. Okay, this might help to rewrite it as a subtraction problem. So this one we would expand instead of condense. So log of 1 minus log of the square root of 1,000. And utilizing your rules from lesson 2, log of 1, any log of 1 is 0. Your base to the 0 power is equal to 1. All right, so minus, this is 1/2. I feel like I'm skipping steps here. We'll do log of 1,000 to the 1/2 power. Then again, using those rules, we can move that 1/2 to the front. So we have 0 minus 1/2 times the log of 1,000. All right, remember, and I'm just going to kind of do this out to the side, the log of 1,000 is the same as saying the 10 to what power, 10 to what power equals 1,000. And so x equals 3, that means that this is 0 minus 1/2 times 3. All right, this is 3. So 0 minus 3/2 is negative 3/2, and that's your final answer for that one. Okay. All right, so again, we're expanding or condensing based on what is most beneficial to us. Okay, so go through another one. We have log base 2 of 8 to the 33. All right, well, obviously I don't want to take 8 to the 33rd power in my calculator and then try to figure out 2 to what power is that. All right, so go ahead and write this in expanded form. Okay, so this expands as 33 log base 2 of 8. And then, so just out to the side here, we can say log base 2 of 8 is the same as saying, if we set that equal to x, so 2 to what power is 8? So x equals 3. So that means that this is 33 times 3, which is 99. All right, go ahead and try to figure out this last one on your own. Okay, so using the rule from yesterday, if your base here matches what you're taking the log of, then your answer is your exponent. So this would just be e to the 200. Well, then that rule applies again, and your final answer is just 200. Okay, so expand each expression as much as possible, leaving no exponents in your final answer. So we're not going to actually solve these out. We're just going to rewrite them in expanded form. And so what that means is that we're taking like log base 6 of 4 root 17, and then rewriting that, for example, as log base 6 of 17 to the 1/4 power. Then moving our exponent out front following that rule. So 1/4 times log base 6 of 17. 17 being prime, this is as expanded as we can get that one. And so this is the expanded form for this. Okay. So applying that same principle here, we have log base 7 of the square root of x squared minus 9. All right, we can rewrite that as log base 7 times x squared minus 9 to the 1/2 power because it's the square root. Moving then our 1/2 to the front. That polynomial is a difference of squares, so it actually factors, and we can rewrite this again as log base 7 of x plus 3 and x minus 3, it being a difference of 2 squares. Well, now we've introduced multiplication in here. So there's 2 ways you can expand this as your final answer. You can do 1/2 times log base 7 of x plus 3 plus log base 7 of x minus 3. Or just keep that 1/2 on everything and do 1/2 log base 7 of x plus 3 plus 1/2 log base 7 of x minus 3. All right. Now the subtraction, we can't expand that. All right, so we leave our answers just like that, okay, because of the parentheses. But if you end up with a polynomial or something that is factorable, go ahead and factor it and expand on that. All right. Okay, divisions, remember, separate into subtraction. So if you have 7 divided by 4a to the 5th, before I deal with expanding the denominator, I'm going to expand that first using the subtraction. So log base 4 of 7 minus log base 4 of 4a to the 5th. All right, and then go ahead and work on expanding this portion of it for me. All right, so hopefully you got here. We just are separating that with addition because this is multiplication. All right, and then we have a couple more things to simplify. This follows our rule where our base matches what we're taking the log of. So if those two match, then our answer is just 1. So we have log base 4 of 7 minus 1 plus, and then we have this exponent here that needs to move to the front, 5 times log base 4 of a. And so this is actually your final answer. You're welcome to move that minus 1 to the back side, but it doesn't really matter. All right, and then last one here, go ahead and do this on your own. Okay, so first changing any radicals I have to rational exponents. So the fifth root is to the 1/5 using parentheses. So I make sure that it's applied to both the a and the b. Then I moved both of my exponents to the front of their terms. So I have 1/5 times natural log of AB minus 2/3 natural log of C. Last, I split up this multiplication into addition, being careful to distribute that 1/5 to both the A and the B. And so it's in front of both of those terms. Okay, so that is my expanded form. These mean the exact same thing. Okay. Again, the reason we do that is sometimes it's easier to evaluate it that way. All right, so using the laws, we're going to go the other way now. Using laws of logs, we're going to condense these back together. And so we do this for the similar reason. It's often easier to simplify or solve if we can write them all as one log. And so again, we have to just kind of look at the scenario that we're dealing with and see which way is easier to deal with it in. So subtraction moves to division. So we have x squared minus 4 divided by x minus 2. All right, well, the top of this factors, so we can do that out as well. This means the log of x plus 2, x minus 2 over the x minus 2, excuse me. That log can apply to both the top and the bottom, so we can just leave it out front. Those x minus 2's will cancel so that our final answer is just log of x plus 2. And hopefully that illustrates how this is more helpful to put together. All right, so when you get big long expressions like this, just take it one step at a time. All right, so the first thing I typically do here is move all of my exponents back to above their perspective terms. And so, for example, log base 5 of a cubed minus log base 5 of b plus, I would move that 1/4 and rewrite this as log base 5 of c to the 1/4 power minus log base 5 of a squared to the 6th power. All right. The next thing I do is anything that is being subtracted needs to be divided, and anything that is being added should be multiplied to the top. So I'm going to rewrite this as log base 5 of a cubed times, and then this is being added c to the 1/4 divided by, and I have subtraction here, so there's a b, and then there's an a to the 12th. I'm going to go ahead and rewrite that as such. Okay, I have a couple things I still need to simplify. I have some like terms on my top in my numerator and on my denominator that I can combine. And then I have a variable that still has a rational exponent, so I'm going to convert that back to radical form. And then I just have this b that kind of stands alone. Okay, so I'm getting rid of all of that stuff and simplifying here as we go. The 3a's would move to the bottom and subtract. So I end up with log base 5 of the 4th root of c, sorry about that, over b, and then 12 minus 3 is a to the 9th, and I'm going to put that in alphabetical order. A to the 9th, b. It doesn't matter what order, I like it in alphabetical order. Okay? I'm going to go ahead and have you try these last two on your own, and I'm going to write the answers out. Okay, so looking through here, hopefully you can see that I moved my exponents first so that they're in the exponent position. Anything that is being added or anything that is positive is up on the top. Anything that is negative is on the bottom. And then I look for my like terms. And so the 12 and the 2 can divide, and then anything else that needs changed or written a different way. So rational exponents put back in radical form. Did the same thing here, moved my C, moved my R, put all my addition in the top to the B and the D to the C, and then any subtraction to the bottom. This one doesn't simplify any further. The last thing we need to look at real quick is what's called the change of base formula. This allows you to change log base A of x into any other log base. And this is helpful because log base 10 is the one that is in your graphing calculator or scientific calculator. Coming back up and added parentheses here. This is important because if you have an 84 or an 84 plus, you can just do your change of base in your graphing calculator. Keystrokes are alpha, let me look, alpha window 5, I believe. But in an older calculator or a Casio, you're going to have to use what's called the change of base formula, all right, which is this right here. And so you're just changing log base A of x to log base B of x over log base B of A. So these logs can match. I always just use log, which is log base 10. You could also use natural log though. So you just change your base formula to evaluate log base 5 of 8 and then give an answer and then just use your calculator to solve it from there. But you have to change the base to solve it. And so log base 5 of 8 changes so that we have this on the bottom and this one on the top. And so we're going to do log of 8 divided by the log of 5. And again, I'm just using base 10 here. You can use natural log of 8 divided by natural log of 5, and it will work out just the same. Okay, so I'm going to pull up my calculator. And so now I have the capability to hit my log button. So log of 8, close your parentheses, divided by log of 5. If you don't close those first parentheses, it'll take the log of 8 times log 5 all together. It'll take the log of the whole thing. Anyways, so nearest thousandth is 3 out, so 1.292. This is a TI 84, so if you're using this one or you have an 84 yourself, again, you could have just done log base 5 of 8 in here by hitting alpha window and going to number 5, which is log base, and then putting the 5 as the base and the 8 here, and we get the same answer. I also think it's in your math list. So math A is also log base. Option A. Okay. So that's a nice function to have if you have that capability. Otherwise, that's it. It's a lot about using those exponent rules. When you multiply, you add. When you divide, you subtract. Power to power, you multiply. And now applying that, to logarithms. Have a great night.